Continuing our conversation about two-dimensional space, we want to introduce today how to graph a line. I know that you may have graphed lines in a previous math course, but we're going to start back at the basics of graphing a line and then move into graphing a line using different forms in Unit 5. We also today want to talk about finding x and y intercepts. Let's start with graphing lines. When we go to graph, remember this is a straight line, one of three things is going to happen. The first option is that our equation will fit the general form ax plus by equals c. And we'll learn next unit that that is standard form of a linear equation. In this form, both x and y variables are in the equation. So the line that we graph must touch both the x and y axis. So if you take a second to visualize a line that will touch both the x and y axis when we graph it, that line has to be a diagonal line. We are going to, for now, graph a diagonal line using a table of values. You are going to pick x values, substitute them in, and find their corresponding y values. I am going to ask that when you graph, for now, your table includes one negative number, your table includes 0, and your table includes one positive number. Let's go ahead and look at an example. In example 1 down below, I see that my equation contains both an x and a y. Just by looking at this and seeing that, I know that when I graph, my line is going to be diagonal. For now, we are going to graph a diagonal line using a table. You are going to randomly select an x value for your table. I am going to randomly select to choose that x is going to be -1. And I didn't mean x value, excuse me. You're going to randomly select a negative number to put in your table. I have chosen -1. You are going to always include 0 in your table. And then you are randomly going to select a positive number. For this one, I'm going to try 2. Now that I've got randomly selected x values, I can plug those x values into my equation to find the corresponding y value. 2 times my x value of -1 plus y should equal 7. 2 times -1 makes -2 plus y is 7. And when I add that over, y is equal to 9. So -1, 9 is a point on my graph. I am now going to let x be 0. 2 times 0 plus y should be equal to 7. 0 plus y equals 7, which means the y value here should be 7. So the order pair 0, 7 lies on my graph. Finally, I'm going to let x be 2. So we'll come over here. 2 times 2 plus y should equal 7. That becomes 4 plus y is equal to 7. And when I subtract the 4 on both sides, I get that y is equal to 3. So the ordered pair 2, 3 is also on my graph. When I plot the points, -1, 9 is located right there. 0, 7 is located right there. And 2, 3 is located right here. Those 3 points do appear to lie on a diagonal line, so we will connect those points. And again, we said it should be diagonal because there is an x and a y in the equation, so the line ultimately has to touch both the x and the y axis somewhere. Diagonal line. We're going to, for now, graph that with a table. All right, a second thing that can happen when we go to graph our line is that our equation might look like x equals a number. For example, x equals 5. Notice that the only variable in my equation is an x. Since there's only an x in the equation, the line may only touch the x-axis when I go to graph it. If you visualize this, a line that only touches the x-axis is a vertical line. So one that looks like this. In order to graph these, you're simply going to put a point on the x-axis where the number is, and you are going to draw a vertical line through that point. Let's go ahead and look at an example. In number 2 down below, you can see that my equation fits the form x equals 4. Since x is the only variable in my problem, I know that this line should only touch the x-axis. Therefore, it's going to be a vertical line. No matter what, x is going to be 4. I can pick any y values I want as long as x is 4. I can find 4 on the x-axis and draw a vertical line through it. If you're not comfortable with that, then plot the points that are in your table. It said that x had to equal 4, so we picked some random y values. The ordered pair 4, negative 1 is located right there. The ordered pair 4, 0 is located right there. And the ordered pair 4, 1 is located right there. Notice all 3 of those points stack up to create a vertical line through 4 on the x-axis. The final thing that can happen when we go to graph is that our equation could look like simply y equals a number. For example, y equals negative 2. Since there is only a y in our equation, our line is only allowed to touch the y-axis. Visualizing a line that touches only the y-axis, you might recognize that the line has to be horizontal, like this. In order to graph a horizontal line, you are going to put a point on the y-axis where the number is located, and you are going to draw a horizontal line through that point. Let's jump down to example number 4. Notice my equation is y equals negative 2. This fits the scenario we just talked about. I may only touch the y-axis, so I need a horizontal line to do that. If I'm not comfortable with just coming down to the y-axis, putting a point on negative 2 and drawing a horizontal line through it, then I can create a table of values. I know that no matter what, y has to be negative 2. I can now come in and randomly select some x values. So I'll pick a negative number, 0, and some sort of positive number. And when I graph those same 3 points, negative 3, negative 2, 0, negative 2, and 1, negative 2, notice they stack up along a horizontal line that goes through negative 2 on the y-axis. You guys go ahead and try number 3. What type of line will this be? Vertical, horizontal, or diagonal? Then fill in the table and graph. The next thing we want to talk about is finding x and y intercepts. This is another method that could be used for graphing. The x-intercept is a point where the line crosses the x-axis. So a single point. Remember, points fit the form of an ordered pair. We are going to have some x value here. And when the line crosses the x-axis, the y value is equal to 0. Let's go ahead and look at an example. Negative 4x plus 2y equals 12. If I want to find the x-intercept, that is the point where y is 0. So the way I remember this is if I'm looking for x, the other person, y, has to be 0. So negative 4x plus 2 times, I'm going to put a 0 in for y, should come out to be 12. I should notice that this term cancels out. 2 times 0 is just 0, and negative 4x plus 0 is negative 4x. So my x-intercept can be found by just taking negative 4x equal to 12, meaning the x needs to be negative 3. The x-intercept is a point, so we need to represent this as an ordered pair. And in that ordered pair, my x value was negative 3, and my y value was 0. To find the y-intercept, that is the point where the line crosses the y-axis. When the line crosses the y-axis, the value of x is 0. Since it's a point, we're going to represent it as an ordered pair, and we know in that ordered pair, x is going to be 0, and y is going to have some value. Again, I think about it, if I'm looking for the y-intercept, the other guy, which in this case is x, has to be 0. So to find the y-intercept for this example, you are going to come down here, and you are going to, since you're looking for y, you are going to let your x value be 0. Again, negative 4 times 0 is just 0, and 0 plus 2y is 2y. So really this cancels out and we're left with 2y equals 12, meaning that y is equal to 6. We now have our ordered pair. When x was 0, my y value is 6. Let's go ahead and look at 1 and 3 together. I'll leave you 2 and 4 to do on your own. In number 1, in order to find our x-intercept, remember the other guy has to be 0. So y has to be 0. When I want to find the y-intercept, the x value has to be 0. Right? So we'll just plug in. To find the x-intercept, remember our y is going to be 0. So 3x minus 5 times 0 equals 9. This term goes away, so 3x equals 9, meaning x needs to be 3. So this equation will cross the x-axis at 3, 0. To find the y-intercept, we're going to let our x value be 0. So 3 times 0 minus 5y is equal to 9. If we multiply 3 times 0, this cancels out. So negative 5y is equal to 9, meaning y is equal to negative 9/5. Meaning that the line would cross our y-axis at negative 9/5. One final example. Let's look at our x-intercept when x equals negative 8. Remember, to find an x-intercept, we're going to let our y, or our other guy, be 0. To find our y-intercept, we're going to let our x value be 0. Okay. So there is no y in this equation to plug that 0 into, and so my equation simply says that x is going to be negative 8. Let's think about that. We talked a minute ago and said that this x equals negative 8 would be a vertical line found by going to negative 8 on the number line and drawing a vertical line through it. Do you agree that that line crosses the x-axis at the ordered pair negative 8, 0? Thinking about the y-intercept, we want to plug a 0 in for x. If I plug a 0 in here, this is going to say 0 equals negative 8. That's not true. Therefore, we would say for the y-intercept that there is none here. And when we look at the graph, we can see that that line clearly does not touch the y-axis. Therefore, there is no y-intercept. You guys go ahead and try 2, 4, and 5, and then check your answers. Your x-intercept here should be 3, 0, and your y-intercept should be 0, negative 1. For number 4, your x-intercept should be none, and your y-intercept should be 0, 4. Finally, for number 5, your x-intercept is -3/2, 0, and your y-intercept is 0, 1.